Okay, today we are doing a little bit of review for the test. The test for this coming, the test that is coming is called Communications number 4, and it's all about trig. Okay, as I take a look in here, slide this thing over a little bit, I have a picture drawn of where negative 7 pi over 6 would be. All right, and that's all the way around to here. Now, this angle right here is the reference angle. The person should have labeled that as pi over 6. Notice it is positive. All reference angles are positive. That's by definition. Okay, so there's your reference triangle, and there's your reference angle. We'll be using those a lot more later, but for right now you just need to know how to draw those. Okay, any questions on that problem that we were grading real quick there? Okay, for those that I didn't show the beginning of this, all it was reminding kids where all the different radians are on that unit circle. Okay, so I'm going to pause for a second. You hand that back to the owner. Okay, so this problem is a typical type of thing we need to know, but it's one of the ones on the easier end of the scale. So let's talk about some of the kinds that you also have to know for the tests coming up that are on the harder end of the scale. Here's still a relatively simple one. If I put a 5 here and I knew this was a 45, 45, 90 triangle, you should be able to figure out what number would go there. Of course, you'd use trig. It's either sine, cosine, or tangent. This is the part where you need your notes out. And you don't have to write the original problem down, but when I ask, okay, try to set this up, that's where you got to start writing. I'm going to ask you to turn it my way. You're going to have like sine, cosine, or tangent of 45 equals something over something. And let's just use the same variable together. Instead of putting question mark, why don't I put an x? I'd like you to find x. Now, one thing, make it darker and make your brightness go higher, because I can't read that. As you turn it my way, remember that if you have left, like let's say you decided to use cosine for this one. If it had been cosine, and you had left the answer as like 5 times cosine of 30, or 45, or whatever, that would be wrong, because you know what cosine of 30 is. You should be able to get this all the way down to a fraction numerical answer. So you would never leave cosine of 30, or tangent of 60, or sine of 45 in your answer. You would actually figure out what it is by using the little reference triangle that I would draw off to the side, 1, 1, square root of 2, and that'll remind you what cosine of 45 is, or whatever it is that you need for this one. Okay, so write the trig function, then solve it for x, and make sure your answer doesn't have a function in it anymore. It's just a numerical answer. Okay, in a moment, these are a little bit more complicated than I like to try to do myself, so I'm going to have you turn it towards somebody else. I'm going to assign you somebody. For today, it's going to be diagonal people. Okay, so look in this row. This is how the diagonal. See, there's 2, 4, 6 here, and there's 5 there. You're separate for now. You're going to be diagonal, so over here. You're going to be diagonal over there. Okay, and you're diagonal with him, and you're diagonals. You two can't be diagonal, so I'm just going to have you compare with each other. Okay. Okay. And here, and you two diagonal, and you two diagonal from each other. Okay. And then over here, we're going to cross, and you're going to go with him, and you're going to go with her, and you two are diagonal from each other, and then you two. Okay? All right. The person I just had you assigned with, remember you want x alone. Show them what you think x is. Okay, let's show the people at home what you guys probably already knew. Is this sine, cosine, or tangent? Well, first thing you ask yourself is pick an angle. I'm going to use that one. I have opposite and hypotenuse. That tells me sine. I always have to have the angle next, 45. And then I always have to have a little fraction, opposite over hypotenuse. Those are just my helper monkeys there. And the opposite one here is x over the hypotenuse is 5. There we go. Sine 45 equals x over 5. Now you should times it by 5 on both sides. 5 goes here. Do you get, though, that you can't leave it as 5 times sine 45? Because sine 45 is knowable. We know that. We know it from looking at that. Sine of 45, sine is opposite over hypotenuse. Opposite is 1 over hypotenuse is root 2. So it's really 1 over root 2. That's what sine of 45 is. So I'm going to put that right here. So I'm going to go 5 times 1 over root 2. Final answer, 5 times the 1, because the 5 is really over a 1. 5 times 1 over 1 times root 2 is 5 over root 2. And those that are following along in another state, some people don't allow you to leave your answer that has a square root in it. It's called rationalizing the denominator. And if you are in one of those kind of states, you might want to multiply by root 2 over root 2. Do my students have to do that? No. We don't have to clear denominators of radicals. In other words, you can have a square root in your denominator and it's okay. But if you had to fix that, you just multiply by this. And what happens is the denominator becomes square root of 4, which is nice now. It's 2. And the top part has a square root. 5 square roots of 2 over 2, if you do it that way. But you don't have to do that in my class. Why? Because the AP test that you'll eventually take on calculus does not require rationalizing denominators. So that's the way I understand it anyways. And that's what we were told as the Precalc class. So, all right, let's move on to a different kind of question. This one isn't going to quite tell you as much info, but as soon as I tell you it's an equilateral triangle, you know how many degrees each angle is. And yep, what is it? Say it. 60. And if I then split it down the middle like this, you now have created a 30, 60, 90 triangle. I hope you can see that. Now, if this side is 8, it wouldn't be too much to ask to tell you how high is the height. It appears I didn't even give you any angles, but I did. By saying it was equilateral, I told you what the angles were. So now you got angles and you got sides, you can do trig. So please figure out, what's the height? That spot right there. I'm going to pause for a second while you try that. All right, so here's what you should have had. You should have thought to yourself, all right, do I want sine, cosine, or tangent in this? Then I need to find the height. I'm going to call it h for the height. You could have called it x, could have called whatever letter you want. But I'm going to go from this angle's perspective. If you used the 30, you would have done something different. It's fine to use the 30, but I'm going to use the 60. And then I'd have opposite and hypotenuse. So I go sine of 60 equals opposite over hypotenuse. I like to use those. You don't have to. The opposite side here from the 60 is the h. Over the hypotenuse is the 8. And then all I have to do is multiply by 8. So that 8 ends up jumping over here after I multiply by 8 on both sides. And why do I get this wrong now? What haven't I finished? Sine of 60. Sine of 60 you need a separate triangle for. I'm going to draw myself my reference triangle for a 30, 60, 90, which is a 1, 2, square root of 3. Hopefully you're good at drawing those. And sine of 60, sine is opposite over hypotenuse from the 60. Okay, opposite root 3 over 2. So 8 times root 3 over 2. And then you can reduce a little bit because this 2 goes in here. It's 2 times 4. And I go, the 2's cancel. And now I have 4 root 3. Raise your hand if you had 4 root 3. Okay, that's most of you. All right. That is a typical, R3 type question. So I'm not covering everything here. Like I'm hoping I don't even need to do things like change degrees into radians or radians to degrees. If I said, 2 pi over 5, change it to degrees, what would you multiply by? 180 over pi. That way what happens? pi's cancel. Now my answer will be in degrees, right? If instead they start with something like, 270 degrees, you just have to multiply by pi over 180. How do you know where to put the 180? Well, it depends what you want to cancel. I want degrees to cancel, so I got to put them in the position where one's on the top, one's on the bottom. And then you just do some reducing. All right. Other stuff you have to know, I guess, those sister functions, if I asked you to find cosecant of pi over, pi over 2. No, you wouldn't do that one yet. Sorry. Pi over 3. First thing, you should right away go, oh, pi over 3 is what? 60. So it's really cosecant of 60. But do I know cosecant? Well, not personally. Now, if you want to, you can do SOHCAHTOA. Because, like, if we had changed this to sine, for instance, you're just going to go, oh, I know sine. It's opposite of hypotenuse. That's what you're going to do to figure this one out. But if I have it memorized, SOHCAHTOA doesn't work for this, but CHO-SHA-COW does. I know it seems ridiculous, but the only thing that's important to keep track of here is that there's 2 C's. That's why they don't do this as often as they do for SOHCAHTOA. SOH are 3 different letters, right? Here we have 2 C's. Well, if you just remember that this one's cotangent, the last one's cotangent, then this other C must be what? Cosecant. So I'm going to do it that way just to show you it could be done that way. So now I need my reference triangle because I just need to do a hypotenuse and an opposite and do something with them. So I need my reference, 30, 60, 90. Here's my 30, 60, 90, 1, 2, square root of 3. And then I go, okay, cosecant is this guy. So it's hypotenuse over opposite. Hypotenuse is, from the 60s perspective, the hypotenuse is 2 over the opposite. No, wait. Hypotenuse over opposite, sorry. Yeah, I'm doing it right. Hypotenuse over opposite. And the opposite side from that is root 3. And there we go. 2 over root 3. That's if you use CHO-SHA-COW. Another way to do it is to say, I don't really want to do cosecant. Instead, I'd rather do sine. So then, what you can't do is just say, I'm going to do sine of 60. Because cosecant of 60 and sine of 60 are not the same. Okay, but what you could do is do 1 over sine of 60 and figure out that answer. So that answer is 1 over whatever sine of 60 is. Okay, so sine of 60, now I go draw this, 30, 60, 90, 30, 60, 90, 1, 2, square root of 3. And from the 60s perspective, the sine is opposite of hypotenuse, that over that. So root 3 over 2. And what does 1 over mean? You flip it. So the last step is to actually flip that root 3 over 2 into 2 over root 3, and there's your answer again. 2 ways you could have done that one. Okay, why don't you try this one? Secant of pi over 6. Right away, pi over 6 should have got changed to what? 30. Secant of 30, I don't want to do secant of 30. Unless I remember CHO-SHA-COW. All right, I am actually going to use CHO-SHA-COW. And SHA means hypotenuse over adjacent. Right? And then I just have to find my triangle, 30, 60, 90. 1, 2, square root of 3. And from a 30 degrees perspective, what's the hypotenuse? 2 over the adjacent side from the 30 degree perspective is root 3. And there's my answer. Done. Don't have to flip it or anything. Okay, that's the good part about memorizing CHO-SHA-COW. If you'd rather, you could have done it this way. Just move this over because I'm going to need it again in a second. I could do, okay, cosine's the one that goes with this. Cosine of 30, but then I got to remember to flip it, 1 over it, because otherwise it's not the same. cosine of 30, adjacent over hypotenuse is root 3 over 2. So that's 1 over root 3 over 2, and that reminds you to flip it. 2 over root 3. There you go. Raise your hand if you had that one right. Okay, now, if you didn't, that's okay. Just remember you could ask me during work time for extra help, and maybe you already know your mistake. So how about the kind where they don't give you the angle? Cosecant of something is 1. No, wait, it's not a good one. It's 2. There we go. On this kind, first thing I'd be doing is putting that 2 over 1, because I always want them set up where you have a fraction at the end, because that means they've given you 2 sides of the triangle. Draw the triangle for this and figure out which angles you must have then if it's that triangle. I'm going to pause, Wade. All right, go ahead, Mr. J. 30, 60, 90. Why are you picking that triangle?
Because the 2 numbers are in that triangle.
Yes, this 2 and a 1 are in that triangle. So 30, 60, 90 has a 1 and a 2 in it. It's even better to say that the ratio is in it. Because what if we decide to use like root 3 over 3? That's not in any triangle you know. Remember how that works? If they use a ratio you don't know, you got to pick off the 2 triangles. I'll put up the other one up here. I'm just saying, if we had changed the question to this, and you were trying to figure out, well, what the heck is root 3 over 3? You know this ratio here, this to that, there is one ratio like it over here somewhere. And if you think you got it, like, oh, I think that must be the same as root 2 over 1, you go like this. And you cross multiply them and you see if it's really true. Is root 3 equal to 3 root 2? Not the same thing. So that didn't work. Maybe if. What if it was root 3, 1 over root 3? And now look at when you cross multiply them. Root 9 and 3. They're the same. So what does that mean? If you saw this, you could replace it with that, so you know you're in that triangle that has a 1 and a root 3 in it. Okay, anyway, that's just a side step to show you something that could be complicated. All right, now, cosecant of 2, you had me draw the correct triangle. Now, Mr. J, how do I figure out what angle it is? It's either 30 or 60, because I know that triangle.
So, which means you look at 30 or 60, so I started with 30.
You started with 30.
So you look at, it's 2 over 1, what I do is flip it to do sine.
Cosecant, yeah, we don't like doing cosecant, we want to do sine. In fact, I would go change this to sine of theta is equal to what? 1 divided by 2. Notice you flip this one and you flip this one. And now you get this. I'd rather do it that way. And in fact, did I mention this one's going to come up a lot? Sine of what is a half? 30. So you know the answer is 30. But in case you didn't memorize that, how do you go from there?
So you look at the opposite of 30, and it is 1, and then the hypotenuse.
So opposite over hypotenuse does work out to be 1 over 2. So yep, I must be using the 30. And the final answer then is theta equals 30. And why do I mark it wrong? Because if you don't have the degree sign, you won't get the full credit. Okay, so that's a pretty extensive review for the test that you're having tomorrow. It's not perfect. I didn't cover everything, but it's covering a lot. So now here's your review packet. This is the most important assignment of this semester so far. Okay, you just have to make sure you do this thing thoroughly and check it with the answer key that's posted. I do both, because if you just do it, you'll think you did it right. Check it. And then if you get some wrong and you're tragically like, I don't get this at all, come in the morning. Oh, wait, it's a Wednesday. I lied. You can't come in the morning. The only option would be masked. Now, I don't, because of the weird nature of this particular mask, because I was gone yesterday and didn't have a chance to invite anybody, I've only invited one kid. So I'm going to make this an open mask for you. Normally, I don't let you just show up. But you can come in tomorrow morning if you want to during mask time. You're all considered invited informally, meaning you don't have to show up, of course. All right. So here's your review packet. Just to clarify, my normal procedure for MAST is you have to be personally invited by me. Otherwise, it's not like I'll, be mean to you or anything. I just have to focus on the people that are officially invited, because it's meant to be a time for certain kids to get caught up, get some extra help, whatever. All right, that's all I have for our little review for today.